So our steps that we are going to go through when I ask you to graph a polynomial. First thing is we need to factor it so we can get the zeros. Okay, it might already be factored for us. It might be one we can factor nicely. If not, that's why we did all the P's and Q's and factored those things in the last section. So we have to be able to use that. Then we will decide if the graph will bounce or go through at each of those zeros. What would make the graph bounce? Even multiplicity. What makes the graph go through? Odd multiplicity. We'll find our end behavior of the graph. And how do we decide our end behavior? We look at that leading term. If it's an odd degree, it looks like a cube. Even degree, it looks like a parabola, and we know a negative coefficient flips it. We'll find the y-intercept. How do we find a y-intercept? It's when your x is equal to 0. You're going to hit the y-axis at 0. And then we will plot all that stuff to actually draw our graph. It doesn't necessarily have to be done in this order. These are all the things we're going to do. I will tell you, like on a test or quiz, I will probably prompt you. I'll say, part A, tell me the zero. Part B, tell me if it bounces or goes through. So you won't necessarily have to remember all the different things. I will prompt you on that. But these are the pieces that we need today. So, if I ask you to sketch this graph, this one is already factored for us. We're going to start off a little bit nice. So if I want my zeros, when it's factored, that's what the x is. A 0 is just the number. So what would make 2x minus 1 equal 0? What about x plus 1? And x plus 3? Okay. Then, what's the next thing I wanted to know? The graph will bounce or go through. So all of these have a multiplicity of 1. 1 is odd, so what's going to happen? So you can list it in order. I'm just going to write we go through all of them. Okay, I need the end behavior. So think about, that's based off the leading term. So we have to think, if we multiply this out, we would have a 2x times an x times an x. So we would have a 2x cubed. So what's it going to look like? Chair, down, up. Right? Because a normal cube graph looks like this, and we're not flipping it. Next thing, a y-intercept. How do we find that y-intercept? So if I put in 0 for all my x's, I get 0 minus 1, so negative 1. 0 plus 1 is 1. 0 plus 3 is 3. Negative 1 times 1 times 3. Now we're going to graph it. Okay. How do I plot zeros on my graph? Yes, zeros are your x-intercepts, where we hit our x-axis. So I'm going to hit the x-axis at positive 1/2, negative 1, and negative 3. My end behavior. So I know my graph's going to start back here and end up here. Okay, that's what that end behavior tells me. My y-intercept, that's where we hit the y-axis. So we hit the y-axis at negative 3. A polynomial is a nice smooth curve. Okay, so we're drawing in a curve from here. No zigzags, no straight lines. It also has to be a function. Sometimes I see people that like get a little wonky with their lines and draw something like that. Is that going to be a function at the end? No. We have found all this stuff. We've plotted it. I know my graph starts down here, so it's got to come up, hit my intercept. Now, we said on this graph it will go through all those intercepts. So I'm just going to go through that point. And at some point I have to come back and hit this one. The only place I can touch the x or y axis is where I have dots. Okay? We're going through all of it, so I have to come back down I have to hit this one. Now, do I know if I go past it and come back, or if I go straight to it? No, we aren't perfect on our graphs, but we are drawing the correct shape with the correct points here. Come up, we have to hit this one and it keeps going up. Did that match the end behavior I said? Yes. Now, could you have drawn a graph that looked more like this? Absolutely. Okay, I'm not measuring the height of our graphs. We are looking for those key features. So when I grade this, I'm checking, do you have the correct end behavior? Do you have the correct intercepts? Did you only touch the x and y axis at those points? And did you draw a curve going through it, not a zigzag? Okay? Any questions there? Okay. This is all we're doing today, so let's try some more. If I want to sketch this one by hand, I'm going to ask some other questions about it at the end, but first we have to sketch it by hand. We have two options for how to start here. We need to factor it in order to get our zeros, don't we? We know we can go back and use P's and Q's if we need to. Does anyone see another option here? Could we do grouping to factor this one? Yeah. So let's go ahead and just do grouping. Might be a little bit faster. So I can take x cubed out of the first one. We'll take 8 out of the second one. Okay. Now what? We have two terms. They both have x minus 2, so you can take out the x minus 2. Leaves us with x cubed plus 8. Is this to the point where we could find our zeros? That's ultimately our goal here. So we can go on and get our zeros here. So x-intercepts. What would make x minus 2 equal 0? Positive 2. Okay, x cubed minus 8. So what would, or sorry, x cubed plus 8. So if you set that equal to 0, we get negative 2. Technically, we could use the sum of cubes formula to factor that, but we are able to just find our 0 from here, so that's okay. When you do the cube formula, remember I never made you memorize it. I gave you that formula. It was like, you have a cubed plus b cubed, it factored into a plus b, a squared minus ab plus b squared. You guys remember that one? We did a little of it. As it turns out, this remaining a squared minus ab plus b squared, it's always going to be imaginary zeros. So can we graph imaginary zeros? No. So we don't lose anything by just solving it from here. All right. So what's my graph going to do at these? Bounce or go through? Through, because we're not looking at if the number is even or odd. We're looking at if the multiplicity is. So if anything had a square or not. And it didn't, so we will go through. In behavior, look at the original. It was x to the 4th. So what would x to the 4th look like? Parabola, both ends going in. Y-intercept. Okay, you can look at the factored, you can look at the original. If we plug in 0 for all of our x's, what do we get out? Negative 16. Alright, so now we have to grade. I'm going to hit my x-axis at negative 2. Positive 2, y-axis at negative 16, you might need to count by something other than ones. I'm going to count by 4s. Okay. In behavior is up, up. So both ends should be pointing up. So if I draw my graph, it's coming from up here, it's gotta hit this point, we go through it. Have to cross my y-axis here, come up and hit this one, we go through it again. So something like this. Is my shape perfect? Probably not. But I'm looking, do I have the right in behavior? Do I have the right points on my x and y axis? So far, so good. I did ask a couple other questions on this. What are the x-intercepts? It's the same thing as 0, it's just a different term. Where is p of x less than 0? So I'm asking, where is this graph less than 0? We can look at that graph. I'm asking, where is it below the x-axis? Can you tell me? Everything between -2 and +2, right? I didn't have an equal to, so it'd be parentheses. Then I asked, where is p of x? So where's my polynomial greater than 0? So where's this polynomial above the x-axis? You're giving me the x's. So from -infinity to -2, that's this part of the graph. 2 to infinity is this part. That's where my graph was above the x-axis. Always use the x's when you write those intervals. Questions there? Okay, if I'm going to sketch it, I need to factor it. What would you guys do? Can we take out negative x? Might be nicer. Give me a positive 2x squared, positive x minus 1. How would I finish factoring that inside? And I need that so I can find my zeros. Okay, if you just have a negative x out in front, what makes that 0? 0. What about x plus 1? Negative 1. What about 2x minus 1? Okay. All of those had a multiplicity of 1. So what will happen on our graph? Will it bounce or go through all of them? Because 1 is odd. All right. In behavior. It's based on the leading term. If we look at the original, x cubed should look like this, but a negative flips it. So it will be up, down. Y-intercept, put in 0 for all your x's and you get 0. So put the x-axis at 0, negative 1, positive 1/2, y-axis at 0. My graph has to start up here. We know we are going through the zeros, through, and it ends down. Is that the end behavior we said? Okay. Let's look at a couple that had different multiplicities to make sure we can still handle this. So if I asked for this one. Huh? I could not find our envelopes. I think they're on the zeros. It's already factored. What makes x minus 1 0? The squared means, okay, and what about x plus 2? When I look at the 1, my multiplicity is even, so what will happen on my graph? When I look at -2, my multiplicity is odd, so this one will go in behavior. Okay, we think about multiplying this out. We have an x squared and x cubed. So overall that would be x to the 5th. So what's my end behavior? How do we find y-intercept? 0 for all of my x's. -1 squared is 1 times 8. +1. So I'm drawing it starts at the bottom. At -2, my graph just goes through. So I'm going to go through this point. I have to hit my y-axis at 8. Coming down, I hit at 1, but what happens to my graph at 1? Bounces. So it's not like a corner, it's just curved, it's just coming back up. Does that match my end behavior that we said we'd have? Why don't you guys take a second, look at the next one, see if you can draw that graph. And if we do okay, then we're done. What makes this equal 0? 0, but it's to the 5th power, so it's 0 multiplicity of 5. What makes x minus 3 equal 0? What about x plus 4? Okay, both of these have an odd multiplicity. 5 and 1 are odd, so it will go through both of those. But here the multiplicity is 4. 4 is even, so that will bounce. In behavior, okay, we have x to the 5th times x to the 4th. So overall, that's x to the 10th. Even looks like a parabola, so up, up. The y-intercept, if you put in 0 for all of your x's, you get 0 to the 5th times -3 times 4 to the 4th. But 0 times anything is 0. Okay, so we hit the x-axis at 0, 3, and -4. Has to start up at the top. When I come down and hit -4, what does my graph do? Bounce. Okay, I come back and hit here, go through, come back and hit here, go through, and does that match the end behavior we asked for? All right. Any questions on that? So I really just want to give you guys time to work so you can ask for help where you're needing it. so this is your assignment.